Okay guys, so in this video we're going to discuss the last way that we can solve a quadratic equation, and that is called the quadratic formula. So this is our fourth way of solving quadratics. And the way that we come up with the quadratic formula, it's a formula derived from completing the square and this will essentially complete the square for any quadratic in one step. So we've talked about how completing the square works for all quadratics, whereas factoring doesn't. And so we don't really like completing the square because completing the square has a lot of steps. So the quadratic formula is really awesome because it just does it for us in one easy, simple step. So the solutions to any quadratic are given by the quadratic formula, which I'll give you a really fun song to help remember it, but it is that the solutions are x equals the opposite of b, negative b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So you'll take your quadratic and you'll plug in the a, b, and c values where it says to, and it'll literally give you your answers immediately. So let's take a look at an example of this. So they want me to solve this quadratic 12x squared minus 10x minus 5. So if I try to factor this, I'd be looking for factors of negative 60 that add up to give me negative 10. And I'm not finding any numbers that work for me. So up until now, my options would be to complete the square, which again would be kind of yucky because I'd have to divide everything by 12 and it's just not going to be pretty. So what the quadratic formula does is it says, okay, take me, the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a, and plug in your a, b, and c values. So for this one, a is 12, b is negative 10, c is negative 5. So if I plug those values in, I get the opposite of b. So since b is currently negative 10, opposite of b is positive 10, plus or minus the square root of b squared, so negative 10 squared, minus 4 times a, which is 12, times c, which is negative 5, all over 2 times 12. So if I simplify what's inside the square root by plugging that in my calculator, all in one step, I get that the square root of 340, 100 minus 4 times 12 times negative 5, all over 24, which I then can take and make my two equations. So my two equations would be x equals 10 plus the square root of 340 divided by 24, and x equals 10 minus the square root of 340 over 24, which I can then plug in my calculator and get for this first one that x is about 1.18 and that x is about negative 0.35. So those are my two solutions, which I get easily by plugging it into the quadratic formula. So let's try using the quadratic formula to solve this quadratic. So my solutions are the opposite of b, so negative 2, because b is positive 2, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a. So if I simplify what's in the square root first, I get negative 2 plus or minus the square root of 16 over 2, which gives me that the solutions are negative 2 plus or minus 4 over 2. So I have two solutions. Either x is negative 2 plus 4 divided by 2, or x is negative 2 minus 4 over 2. So this first equation gives me that x would be 1, and the second equation gives me that x would be negative 3. I'm running out of space there. Negative 3. So those are my two solutions. And actually, anytime you get a whole number as your answer, that tells you that your original quadratic was factorable. So if I try to do the AC method here, I would find that the two numbers that work for this would be 3 and negative 1. So if you do the quadratic formula and you get whole numbers, it just kind of tells you that your original problem was factorable. So as we saw in those two examples, both equations had two real solutions, like two real answers. And so we can use part of the quadratic formula to tell us how many answers, how many real answers there will be. So that part is called the discriminant, because it helps us discriminate, which isn't good normally, but in math it's okay, how many solutions each quadratic has. So the discriminant is the portion of the quadratic formula that is underneath the square root. So if you look back at what the formula is, the part that's underneath the square root is b squared minus 4 times a times c. And so this is special because we know that we can only take the square root of positive numbers. So this is going to tell us how many solutions there are. So this tells how many solutions there are. If the discriminant is positive, if I'm taking the square root of a positive number, then that tells me that there are going to be two real solutions, because that's going to give me plus or minus something, plus or minus a whole number or a decimal. If the discriminant is equal to 0, that tells me that there's only one real solution, because I can't really have plus or minus 0. It's just going to be 0. So that'll only give me one answer. And if b squared minus 4ac is less than 0, if it's negative, that tells me that there are no real solutions. That my solutions are going to be imaginary, because I'm going to be square rooting a negative, which causes imaginary answers. So if I want to know how many solutions a quadratic has, I don't need to actually solve it. I can just take my discriminant, b squared minus 4ac, and plug in the values. So 2 squared minus 4 times 8, and see what I get. This is going to give me 4 minus 128, which gives me negative 124. Which is less than 0. So there are no real solutions. Because if I try to take the square root of negative 124, I'm going to get imaginary numbers.